Introducing a new era in serviceability and performance. The 90 series tractors from Case. This program will cover what's new in these tractors from your viewpoint as a service technician. Let's open the hood and see how easy it is to get to the various components. The 2290 tractor has a tilting hood. Look at the release latch. It's easier to operate than your car, and conveniently located on both sides of the tractor too. Now you can get at the air cleaners, valve tappets, injectors, and radiator easier. The 2090 has a sliding hood for easy access to regular maintenance items. All of the tractors have easily removable side panels for belt adjustment and a swing-out cooler and condenser for easy radiator trash cleaning. Even the hood itself is serviceable. The 4-section bolted construction lets you replace individual sections if they get damaged. Now that we have seen how easy it is to get at things, let's take a look at the serviceability of the air conditioning. You'll like this. The air conditioning compressor is driven with a short belt from the water pump pulley, and belt tension is adjusted by tilting one side of the compressor, similar to the alternator belt adjustment. The air conditioning hoses are all one piece on this series of tractors. This means there will be less chance for leaks because there are fewer connections. These one-piece hoses will also change your disconnect procedure for tractor splitting. Quickly, here's what you do. First, you backseat the suction side service valve on the compressor to isolate the gauge port. Then, hook up one of the gauges on the gauge set. Make sure the gauges are closed. Next, front seat both service valves on the compressor. This will trap the refrigerant in the hoses. The third step is to bleed off the small amount of refrigerant left in the compressor by opening the test gauge. The suction line and service valve can now be removed from the compressor. The discharge line can be disconnected at the quick disconnect. You will find a minimal loss of refrigerant with this procedure, and in most cases, you won't even have to add refrigerant. But always check your sight gauge to make sure. Now let's take a look at the battery service. Just swing out the tray, remove a couple of wing bolts, and then lift off the cover and the battery is exposed for regular maintenance, testing, or removal. While we are on the subject of the electrical system, let's take a look at the starter and alternator. First, the starter. The heavy-duty Delco Series 200 starting motor is used on all models. The alternator capacity has been increased from 55 to 72 amps on cab models and from 55 to 61 amps on non-cab models. Because we have this kind of charging capacity, we are now offering a 6-light optional auxiliary lighting package. By the way, the cab wiring harnesses are standardized on all models. This should make troubleshooting easier. We have made a lot of other changes in the cab too. For openers, heavy-duty handles to operate a rotary-type door latch that has proved itself in automotive use for years. Look, the ignition key and door key are the same. And for security, you can't take the door lock off from the outside of the cab. Also, the door holder is new. We have really moved things around, too. Inside the cab, we have taken the ignition key, the ether start button, and the turn signals off the lower part of the instrument panel and clustered them around the tilting steering wheel, where they are really convenient. We moved the engine stop button to the operator's console so it is closer to the throttle for convenience and safety. The draft sensing lever is out where you can really get a hold of it, and it works easier too. The PTO lever operation is changed too. Pull it out to engage the PTO, push it down to disengage. The instrument cluster is the plug-in type with circuit boards. Here are a couple of tips on checking out the lamps on the instrument cluster. To check the 6 warning lights in the instrument cluster, place the fuel stop button in the off position. Turn the key to the on position. The engine oil pressure, alternator, and transmission oil pressure should come on. In 4 to 10 seconds, the transmission filter light should come on. Now turn the key to the crank position. The alternator light should go out, and the other 5 should be lit. With the engine running and the key on, all warning lights should be off. The one exception you may find is that with the high amperage alternators, the light may not turn off until a higher engine RPM is reached. Accelerating the engine should then make the light go out. The light should then remain out when you return the engine to idle. Operating the engine with the key turned off and several accessories turned on will cause the alternator indicator light to be dimly lit. This ignition switch has an accessory position to allow the vehicle radio or similar accessory to be operated without activating the entire ignition system and warning lights. The only warning light that will be lit is the alternator light. This will alert the operator that battery discharge is occurring. In the opening of this program, we mentioned a new era in performance. Well, here is one of the main reasons. The case control hydraulic system. This system has the ability to monitor system pressure, flow, and load, and adjust its performance accordingly for maximum efficiency. How does a hydraulic system do all this? Well, let's take a look at the pump first. This discussion is oversimplified, but we are sure you'll get the idea. The pump is an axial piston type. That means there are pistons, 9 to be exact, that move back and forth in a cylinder as the cylinder rotates. During half of the revolution, the piston draws fluid from the intake. During the other half revolution, it forces fluid through the discharge. This pump also has a feature which allows it to change the amount of flow as it operates. This change in flow is accomplished by changing the angle of the plate which the pistons ride against. When the plate is straight up and down and the cylinder is rotating, there is no flow because the pistons are not moving back and forth in the cylinder. If we move the plate at an angle, fluid will be moved by the pistons. The greater the angle, the greater the flow. The plate angle is controlled by a spring-loaded control piston. When the pressure at the discharge port equals the spring pressure, the plate is straight up and down and the pistons do not pump any fluid. When the discharge pressure decreases, the control piston spring moves the plate to an angle which causes the pump pistons to move fluid. This is how the pump has the ability to monitor system pressure and adjust itself to the requirement of the system. But performance doesn't stop at the pump. Look at the remote control valves. Each remote valve also has a pressure and flow compensator. What does this mean? It means that the operator can adjust the flow from each individual remote valve to suit the application, regardless of whether it is driving a 4 GPM hydraulic motor or a large hydraulic cylinder. It means you can independently tailor the requirements of each remote valve. You never have to worry about response in the rest of the system or pump damage because both valve and pump work together. The valve meters and the pump respond. We even have stops on the remote levers to keep you from going into the float position when you push the levers fully forward. Yes, that is right. We have a float position on the remotes. valve. And each remote circuit is totally independent. This means faster response, longer pump life,